So in this example, we're going to be determining a schedule. It says, Darius is a salesman for a snack food distributor. His work schedule requires he stocks food for 2 consecutive days at stores on the north side of the city, then for 2 consecutive days at stores on the east side of the city, then 2 days at stores on the south side of the city. Finally, he gets 3 consecutive days off before the scheduling cycle repeats. Assuming he has no planned scheduled days off, if Darius is stocking stores on the east side of the city for the 2nd consecutive day, what part of the city will he be at? And then we have 30 days from now, and then these various questions here. So what we need to do is we need to represent his schedule visually. So if he's going to be for 2 consecutive days on the north side of the city, I'm just going to go N. Those are 2 consecutive days on the north side. Then for 2 consecutive days on the east side, so I'm going to go E and E. And you can use any symbolism you want. It just seems natural to use letters. 2 days on the south side, 2 consecutive days on the south side, S and S. And then finally he gets these 3 days off. So here's a visual representation of his schedule. And you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then of course it repeats. So it is modular. Now it says if Darius is stocking stores on the east side of the city for the 2nd consecutive day, so currently he's right here. What part of the city will he be at? And for A, 30 days from now. So what we could do is we could simply just count off 30 days. 1, 2, 3, 4, 5, and since it's modular, we go back to the beginning. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So he's going to be on his first day off of his 3 consecutive days off. So he'll be right here. But we certainly don't have to count off, though you can. We're going to use our understanding of modular arithmetic. So we're going to say 30 modulo, and since there's 9 days, that's our modulus, 30 modulo 9. 9 divides into 30 3 times, right? 3 times 9 is 27 with a remainder of 3. So all we have to do is where he's currently at, count off 3 days. 1, 2, 3, and here we are. Let's try B. 87 days from now. So rather than count off 87 like we did before, we'll go 87 modulo 9. 9 goes into 87 9 times, right? 9 times 9 is 81, with 6 remaining. 1, 2, 3, 4, 5, 6. So he'll be right here. He'll be on his first day on the north side of the city. Let's try C. Now here, 2 weeks earlier, that's 14 days. So we could easily just count off 14 days, but it's 14 days or 2 weeks earlier. So since it's 2 weeks earlier, we're going to count off 14 days going backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So he's going to be on his second day off. But we can do this 2 other ways using modular arithmetic. If we did 14 modulo 9, 9 goes into 14 1 time with a remainder of 5. So I could just count back 5. 1, 2, 3, 4, 5, and here we are again. Or since I know it's 2 weeks earlier, I could do negative 14 mod 9. And like we did in an earlier example, I'm going to use a number line to help me do this. Just a practical approach. So here's our negative 14. Here's 0. So I'll count back 9. That'll take me to negative 5. I'll count back 9 again. That'll take me to 4. So this is going to be equal to 4. But since I already included the negative here, the counting back, I don't count back when I'm up here on the schedule. I'm just going to count forward. 1, 2, 3, 4. And here we are. So let's try D. 1 year and 2 weeks from now. So assuming it's not a leap year, we'll say 365. And 2 weeks, that's plus 14 more days. And I'm not even going to add these together. We'll just do them separately. Or in parts, as we say. 9 goes into 365. 365 divided by 9. That's 40. 40 times 9. Isn't that 360? So this will give us a remainder of 5. 9 goes into 14 one time with 5 left over. 10 modulo 9 is 1. So he'll be right here, the first day on the south side of the city. And there we go.